Hello again. This is Math 2232 coming to you from the College Edu page. And the title of this lecture is Summer 22 Final Exam Take-Home Problems. As always, please be attentive while watching this video. By way of introduction, this take-home component is being provided as an additional opportunity for student success. Your work product must be uploaded to Blackboard, the take-home area, as a legible PDF on or before August the 6th. Late work cannot be accepted, and those are COD rules, not mine. And as you might expect with a take-home assignment, take-home protocols apply throughout. That means you can visit Jesse Hayes Carver's GSG. You can come to my office hours, or you can work together with your colleagues. The work should be your own, but you can get hints and help. And also our ground support, the Learning Commons math area, is open 70 hours a week. So lots of opportunity to finish this, and it's an opportunity to make significant progress for your success. So let's dive into it. And in my final exam scope statement, this is the red stuff that's right here. So those are going to be equally weighted with the material that you're doing in class. And so that's an opportunity. They won't necessarily be in this order, but that's okay. These are the three problems that we're going to be discussing. So this is take-home problem number 1, and there are 4 parts. So number 1, then, consider the definite integral from 5 to 10 of cosine of 1 plus the square root of x dx. In part A, to estimate this integral accurate to 4 decimal places using the trapezoidal rule, what value of n is required? And you should show your calculation as well as the value of n clearly indicated. Part B, to estimate this integral accurate to 4 decimal places using Simpson's rule, what value of n is required? Again, show your calculations and the value of n. Part C, and part C really is 2 parts, but you want to perform both of these approximations. So approximate this integral using the trapezoidal rule and the value of n that you came up with, and also approximate the value of this integral using Simpson's rule to the value of n that you did. So there's a lot of stuff here. You want to show your work in an Excel spreadsheet format or some equivalent format. Maybe you program in, I don't know, Python or something. You could show a Python output showing that calculation as well. So those are A, B, and C. Part D is actually, you should be able to compute this integral exactly using some of the learnings from our class. So perform this calculation and in part D, show your exact answer. Now, I really am not doing much in the way of grace notes this term because of many reasons, but on this Problem 1, take home, I do provide some grace notes. And the first grace note is take-home protocols apply throughout. So if you need help, you can get help. You know where to go, Jesse Hayes Carver, the Learning Commons, or my office hours. It may be of interest to you to know what the graph of this looks like. And this is what the graph of y equal cosine of 1 plus the square root of x looks like. And so you can see what it looks like, and again we're going from 5 to 10. It also, for reasons that should be obvious whenever you've completed your studies of this numerical integration, it's useful for you to know for this problem what does the graph of the second derivative. Now these symbols show it as second partial derivative, but since there's only one derivative, this is the graph of the second derivative of cosine of 1 plus the square root of x. And this is what it looks like. And this is, to save you the Calc 1 trouble, this is what the second derivative would be if you computed it. And again, these are things that I think you will find are valuable as you're working the problem. Finally, for the problem, this is a picture of the graph of the fourth derivative with respect to x of cosine 1 plus the square root of x, and here is what the fourth derivative looks like when you calculate it. And again, if you reflect on the details of the numerical integration, you say, oh yes, Jim is providing us some useful thing in these grace notes. Okay, so that was problem 1, and that's the end of the grace notes. But here we have a take-home problem, number 2. So we have a tank of water is 15 feet long and has a cross-section in the shape of an equilateral triangle with 2 feet long sides, and the point of the triangle is pointing downward. You want to spend a little bit of time sketching this and thinking about what this tank would look like. The tank is filled with water to a depth of 9 inches. Determine the amount of work needed to pump all the water to the top of the tank. And you're to assume that the weight of the water is 62 pounds per cubic foot. Notice that here you are dealing with weight density, and so you don't have to worry about the acceleration due to gravity. You're to work the problem, showing your work, but also provide a clearly indicated final answer, accurate to the nearest foot-pound. Again, take-home protocols apply. Finally, number 3, you are to find the hydrostatic force on the plate submerged in the water as shown. So here's the plate submerged in the water as shown. The plate in this case is the top half of a diamond formed from a square whose sides have length 2. Consider the top of the blue box to be the surface of the water in which the plate is submerged. And note as well the dimensions in the image will not be perfectly to scale because it has to fit here. And the lengths given in the image are in meters. So this problem is a metric problem, not an English unit problem. Now what we're supposed to do here, and please notice things are a little different here because I'm telling you the mass density of water is to be taken to be 1,000 kilograms per cubic meter. And the acceleration of gravity is to be taken to be 9.81 meters per second squared. You want to find the answer accurate to the nearest Newton because you're finding the force. And again, take-home protocols apply. In closing, now more than ever, time is precious. Each day must count. Do the math. It will make you strong. And now more than ever, take care of yourself because self-care is important, and take care of each other because we're all in this together. God bless you all, and I look forward to seeing you in class.